Okay, solving a trigonometric equation. So in this situation, we have 2 sine squared of theta plus sine of theta equals 0. And we want all the solutions for theta between 0 and 2 pi. So as we get going on this, I notice everything's in terms of sine. That's good news. We don't have to switch from sines to cosines or vice versa. We also have 0 on one side all by itself. So this is going to be a pretty straightforward problem, I'm hoping. The first thing I would do is we have 0 on one side. I would try to factor the other side. Some students struggle with this. So what I would suggest is replace each one of our sine of thetas with, say, a y at the beginning. So I have 2 times sine squared of theta. So that's equivalent to y squared plus sine of theta, which I'm going to put y in that spot, is equal to 0. Okay, from here, if I asked you to factor the side equation, you would say, hopefully, we have y's in common for both these terms. So let's just take a y out. So if we remove a y, that'll leave us with 2y plus 1 inside our parentheses is equal to 0, and we factored it. We could set each factor equal to 0 and solve down. Now, our equation has signs in it, but it's going to be a very, very similar thought process. The zeros on one side, each of these has a sign in common. So let's factor out that common factor of sine of theta. What's going to be left inside our parentheses now is going to be 2 sine of theta plus 1 equals 0. So if we redistributed the sine of theta to each one of these terms on the inside, we would get these same 2 terms back. All right, now that we factored, the next step would be set each factor equal to 0. So sine of theta is going to equal 0, and 2 sine of theta plus 1 also equals 0. We're going to treat these like 2 separate equations. This one's already solved down because we have sine of theta on one side. The other one, we're going to have to do a few steps to get sine of theta on one side. I would first go ahead and subtract 1, move that to the other side, and then finish this up by dividing both sides by 2. That will isolate our sine of theta. All right, so we've isolated the sine of theta in each individual case here. Next, what we want to do is actually evaluate these and figure out what angle would I have to plug in for theta that would give me a 0 coming out. So for zeros and ones, when those are over on the other side here, what I always like to do is I always go back to the unit circle. Drawing a perfect unit circle going on here. And for the unit circle, for any of these terminal points on here, hopefully we're comfortable at this point that it's always going to go cosine of theta is going to be the x value, and sine of theta always goes as the y value. So in our circumstance, we're looking for when is our y value on the unit circle going to equal as 0. So our y value can equal a 0 on the unit circle, either at this point over here, which goes as 1 comma 0, or a point on the opposite side of the x-axis there. All right, so that'd be negative 1 comma 0. But both of those have a y value of 0. Now all we have to do on this to find our values for theta are think, what angles would we plug in to get us over here for this terminal point? So that's going to be at pi. So we can say, well, theta is going to be pi, or theta could be 0, or all the way around would be 2 pi. But just based on our limits here, 0 would be okay. But 2 pi would not be okay because it doesn't have the or equal to on it. So we'd say this first one is just going to be at 0 without rotating around at all. All right, so that takes care of this equation. We have 2 solutions there. On this other equation, sine of theta equals negative 1/2. Well, positive 1/2 is one of these angles that comes out quite frequently. One of these ratios that we're hopefully used to at this point, that if we plugged in, let me think, it would have to be pi over 6. If we filled that in, sine of pi over 6 would give us positive 1/2. But we're looking for when is it going to be a negative 1/2. So off to the side here, I'm just using theta bar is equal to pi over 6. That's reminding me I'm going to use this as a reference angle, and I'm going to have to put it in the appropriate quadrants to give us a negative. So how I remember this is I use the phrase all students take calculus, and all of our trigonometric ratios are going to be positive in the first quadrant. Only sine is going to be positive in the second quadrant, tangent in the third, and cosine in the fourth. So what that is telling us is our sine is equal to a negative. So it's either going to be in the third quadrant or the fourth quadrant. We're going to find one in each of these by using this reference angle. So in the third quadrant, what I'm going to do is go ahead and just draw in. I want to place this reference angle pi over 6 into the third quadrant. And our goal here is we want to calculate what angle wraps all the way into the third quadrant that has pi over 6 as a reference angle. So in quadrant number 3, our theta would be given by, well, it's pi units to go around halfway. And then we're pi over 6 further than that. So my calculation is going to be pi plus pi over 6. Or we could rewrite that as 6 pi over 6 is equivalent to pi plus pi over 6 would give us 7 pi over 6 by combining these fractions together over that common denominator. And again, I did replace 6 pi over 6 in for pi. 1 pi here is equivalent to 6 over 6 makes 1 pi here. All right, so that's our quadrant 3 angle that's going to have a negative sign. We also need a quadrant 4 angle. So to get that, what I'm going to do is, again, use that pi over 6 as a reference angle in the fourth quadrant. And our goal is we want to come up with the angle that wraps, all the way around. You see this was pi over 6 here. We want an angle that wraps all the way around, ends up in the fourth quadrant, and has pi over 6 as its reference angle. So going all the way around would be 2 pi. We want our theta to be 2 pi, but a little bit shorter than that, right? So we're going to subtract away that reference angle, the pi over 6. So all the way around would be 2 pi, but we want to back up pi over 6 and not go all the way around. So 2 pi minus pi over 6. That calculation is going to be, we can rewrite this as 12 pi over 6 is equivalent to 2 pi minus pi over 6 is going to leave us with 11 pi over 6. So that's our angle in the fourth quadrant. That's going, if we plugged it in for this theta and sine of theta, would produce a negative 1/2. All right, so we had 4 solutions here. We have 0, pi, 7 pi over 6, and 11 pi over 6. 4 different solutions. I hope this helps out as you're working on solving trigonometric equations. Just take your time, factor whenever possible. You can get there, but it takes practice. Keep going.